Hello, in this lecture we will find out the value of angle x using two different methods. In the drawing we have triangle PQR. We know that QP equals to PR. It is actually QS equals to SR. And we also know that angle PSQ equals to 45 degrees, angle PQS equals to 3x, and angle PRQ equals to x, and we want to find out the value of angle x. So we will start with the first method. Here we will define angle QPS as alpha, and we will define angle SPR, this angle, as beta. Here we will define angle PSR as x. QR is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the upper side of the straight line QR, then you get that 45 degrees plus x equals to 180 degrees. Here we will subtract 45 degrees from this equation, and we will get that angle x equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that angle x, that is actually not the angle that we are looking for, but this angle equals to 135 degrees. In the next step, I will present to you a new rule that is actually the law of sines. The law of sines is applied in any triangle so you can write down that in any triangle we have a triangle and the length of this side of the triangle is A units, and the angle that is located in the opposite side of this side is angle A, and we also know that the length of this side of the triangle is equal to B units, and the length that is located in the opposite sides and the angle that is located in the opposite sides of this side is B, and we also know that the length of this side of the triangle is C, equals to C units in its length, and the angle that is located in the opposite sides of this side is C. Then, according to the law of sines, A over sine A equals to B over sine B, equals to C over sine C. Okay, I'll repeat again. According to the law of sines, in any triangle, A over sine A equals to B over sine B equals to C over sine C, when A, B, and C are the lengths of the sides of this triangle, and A, B, and C, capital A, capital B, and capital C are the sizes of the angles inside this triangle. Okay, so from this formula we can derive that A over sine A is equal to B over sine B okay. Here we will multiply this equation by sine A, and then we will divide it by B, and we will get that A over B equals to sine A over sine B. Okay, so in any triangle, the ratio between the side lengths equals to the ratio between the opposite angles, because angle A is located in the opposite sides of this side, and angle B is located in the opposite sides of this side. Again, the ratio between the side lengths of any triangle is equal to the ratio between their opposite angles. Okay? And in our drawing, we can write down the following equation, that if we relate to triangle PQS, we know that PS over SQ equals to PS over SR. again, PS over SQ equals to PS over SR, and it is true because of the fact that QS is equal to SR. Here QS equals to SR, but according to the rule that we found out, that the ratio between the side lengths of any triangle equals to the ratio between the opposite angles, we will get that if we relate to triangle PQS, that PS over SQ, if we relate to this triangle, PS over SQ, or PS over SQ equals to sine 3x over sine alpha, and if we relate to triangle PSR, this triangle, here PS over SR, according to the formula that I presented to you, PS over SR will be equal to sine X over sine beta. We know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, the sum of the angles inside triangle PQS is equal to 180 degrees. That is to say, alpha plus 3x in this triangle PQS, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again. In triangle PQS, according to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract 3x and also 45 degrees from this equation, equation number 2, and we will get that according to equation number 2, alpha equals to 180 degrees minus 3x plus 45 degrees. Okay? I subtracted 3x and 45 degrees from equation number 2, and we got that alpha equals to 180 degrees minus 3x plus 45 degrees. Likewise, if we relate to triangle PSR, we know that in triangle PSR the sum of the angles is equal to 180 degrees. So in triangle PSR, the sum of the angles must be equal to 180 degrees. So we get equation number 3 that states that beta plus 135 degrees plus angle x must be equal to 180 degrees. Again, the sum of the angles in triangle PSR equals to 180 degrees, that is to say beta plus 135 degrees plus x must be equal to 180 degrees. Here we will subtract 135 degrees and also x from equation number 3, and we will get that angle beta equals to 180 degrees minus 135 degrees is 45 degrees minus x. So we found all the values of alpha and beta in terms of x. Now we can substitute alpha and beta in this equation number 1, by the values that we found for alpha and beta in equation number 2 and equation number 3. And we will get that sinus 3x over sine alpha, and alpha according to equation number 1 in this equation according to equation number 2 is equals to 180 degrees minus 3x plus 45 degrees, and it equals to sine x over sine beta, but beta according to equation number 3, this equation, it equals to 45 degrees minus x. Okay? This is actually equation number 1. We substitute that alpha and beta in equation number 1 by the values that we have in equation number 2 and equation number 3, and we got this equation. We know we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. Sinus 180 degrees minus theta equals to sinus theta. According to this trigonometric identity, we will get that sinus 3x, that sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. Okay, so I write it down. According to equation number 1, this equation, we will get that sinus 3x over, and this expression equals to, according to this trigonometric identity, it equals to sine 3x plus 45 degrees and on the other side of equation number 1 we have sine x over sine 45 degrees minus x. Okay, so we got the equation number 1 that states that sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. Here we will cross multiply equation number 1 and we will get that sinus 3x times sinus 45 degrees minus x equals to sinus x times sine 3x plus 45 degrees. We cross multiplied this equation number 1, and we got this expression. Here we will multiply equation number 1 by 2, and we will get that 2 times sine 3x times sine 45 degrees minus x equals to 2 times sine x times sine 3x plus 45 degrees Here we will use the trigonometric identity that states that 2 sine A sine B equals to cosine A minus B times cosine A plus B. I repeat again, we will use the trigonometric identity that states that 2 sine A times sine B equals to cosine A minus B minus cosine A plus B. Okay, so we will use this trigonometric identity in order to simplify our equation number 1. Here, in this side of equation number 1, A equals to 3x and B equals to 45 degrees minus x. And we will get, according to this trigonometric identity, that 2 sine 3x sine 45 degrees minus x, it will be equal to cosine A minus B. So it is cosine A is 3x, B is 45 degrees minus x. So it is actually 3x minus x is 4x minus 45 degrees minus cosine A plus B. A is 3x and b is 45 degrees minus x, so a plus b is 3x plus minus x is 3x minus x, that is to say it equals to 2x plus 45 degrees. So we finished with this side of equation number 1, and now we will find out the value of 2 sine x times sine 3x plus 45 degrees according to this trigonometric identity, that 2 sine a sine b equals to cosine a minus b minus cosine a plus b. Here a equals to x and b equals to 3x plus 45 degrees. So we will get that 2 sine x sine 3x plus 45 degrees according to this trigonometric identity will be equal to cosine a minus b. This cosine a minus b x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. So here we got cosine minus 2x plus 45 degrees, but according to the trigonometric identity that cosine minus x equals to cosine x, what does it mean? It means that we can substitute the minus sign by plus sign because of the fact that cosine minus x equals to cosine x. So here we will change the minus to plus, and we will get that this expression, it is actually cosine 2x plus 45 degrees, and so this is cosine a minus b, and we have also minus cosine a plus b, minus cosine a plus b. A is x, b is 3x plus 45 degrees, so x plus x is 4x plus 45 degrees. Okay, so we actually have here cosine 4x minus 45 degrees so we will add cosine 4x plus 45 degrees, and we will add also cosine 2x plus 45 degrees, and we will get that it equals to 2 times cosine 2x plus 45 degrees. So we have here cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, and we will simplify this expression according to the trigonometric identity that states that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. Okay, so we'll simplify cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees according to this trigonometric identity of cosine C plus cosine D, and we will simplify 2 cosine 2x plus 45 degrees according to the trigonometric identity that states that cosine A plus B equals to cosine A cosine B minus sine A times sine B. So first of all, we will deal with this expression cosine 45 degrees cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, and we will simplify it according to this trigonometric identity of cosine C plus cosine D. So here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees So according to this trigonometric identity, we will get that it equals to 2 cosine C plus D over 2, 2 cosine C plus D. C plus D is 4x plus 4x over 2 is 4x, 2 cosine 4x, and minus 45 degrees plus 45 degrees is 0 times cosine C minus D over 2. So 4x minus 4x is 0, and we have minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. So we got here cosine minus 45 degrees, but because of the fact that cosine minus x equals to cosine x, we can write down that cosine minus 45 degrees equals to cosine 45 degrees. So we finished with this side of equation number 1. And now we will deal with this expression 2 times cosine 2x plus 45 degrees. We will simplify it according to this trigonometric identity that cosine A plus B equals to cosine A cosine B minus sine A times sine B. Here A equals to 2x and B equals to 45 degrees. So we will get that cosine A plus B equals to cosine A cosine B, and A is 2x, so it is 2 times cosine 2x cosine 45 degrees minus sinus 2x sine 45 degrees. So actually, in conclusion, we found out that according to equation number 1, two times cosine 4x cosine 45 degrees equals to here 2 times cosine 2x cosine 45 degrees, and here it is actually 2 times sine 2x sine 45 degrees, because here, as you can see in the original equation number 1, cosine 2x plus 45 degrees is multiplied by 2, so we must multiply it by 2 also here. Here we will divide the equation number 1 by 2 cosine 45 degrees, so 2 is cancelled, cosine 45 degrees will be cancelled, and also 2 will be cancelled, and cosine 45 degrees will be cancelled, here 2 will be cancelled, and because of the fact that sine 45 degrees equals to cosine 45 degrees, here sine 45 degrees will get cancelled. So what is left from equation number 1 after we cancel 2 cosine 45 degrees? What is left? It is actually, here we have cosine 4x equals to, here is cosine 2x minus sine 2x. So here we will add to this equation number 1 sinus 2x, and we will subtract cosine 4x, and we will get that sinus 2x equals to cosine 2x minus cosine 4x and we know that cosine 2x is equal to 2 sine x. We know that sine 2x equals to 2 sine x cosine x, so I'll write it down. Again, sine 2x is equal to 2 sine x cosine x, and it equals to cosine 2x minus cosine 4x. Actually, cosine 2x minus cosine 4x, it is cosine C minus cosine D. We can use the trigonometric identity that cosine C minus cosine D equals to 2 sine d plus c over 2 times sine d minus c over 2. So we will use this trigonometric identity in order to simplify cosine 2x minus cosine 4x, and we will get that in our equation c equals to 2x and d equals to 4x. So cosine 2x minus cosine 4x will be equal to 2 sine d plus c over 2, that is to say, it is 2 sine d is 2x, c is 2x, d is 4x, so d plus c is 2x plus 4x, that is 6x over 2, 6x over 2 is 3x, times sine d minus c over 2, d is 4x, c is 2x, so 4x over minus 2x is 2x, and 2x over 2 is x. So in conclusion, we found out that 2 sine x cosine x equals to 2 sine 3x sine x. Here we will divide equation number 1 by 2 sine x, and we will get that here 2 sine x will get cancelled, and we left only with cosine x equals to sine 3x we have the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha, cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, we will get that cosine x equals to sine 90 degrees minus x, and it equals to sine 3x so here we will get that 90 degrees minus x equals to 3x, we got that 90 degrees minus x equals to 3x. We will add x to this equation, equation number 1, and we will get that 90 degrees equals to 4x. We will divide equation number 1 by 4, and we will get that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So we found out that x equals to 22.5 degrees. Okay, we found out that x equals to 22.5 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of x according to the second method. So in the second method, we will define angle QPS as alpha, and we will define angle SPR as beta, as we did in the first method. We have already found out that this angle equals to 135 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PQS, the sum of its angles is equal to 180 degrees. So in triangle PQS, this triangle, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again. In triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 45 degrees from this equation, equation number 1, and we will get that alpha plus 3x equals to 180 degrees minus 45 degrees is 135 degrees. So we got that according to equation number 1, alpha plus 3x equals to 135 degrees. Likewise, we'll do the same thing on triangle PSR. In triangle PSR, we know that the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus angle x must be equal to 180 degrees. Okay, the sum of the angles in triangle PSR must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. Here we'll subtract 135 degrees from this equation, equation number 2, and we will get that beta plus x equals to 180 degrees minus 135 degrees is equal to 45 degrees. So we got that according to equation number 2, beta plus x equals to 45 degrees. Here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 45 degrees times 3 is 135 degrees. So according to equation number 2, 3 beta plus 3x equals to 135 degrees. And according to equation number 1, alpha plus 3x also equals to 135 degrees. So we can create equation number 3 that states that this side of equation number 1 equals to this side of equation number 2, because both sides are equal to 135 degrees. So equation number 3 states that this side of equation number 1, that is actually alpha plus 3x, it equals to 135 degrees, and this side of equation number 2, that is 3 beta plus 3x, also equals to 135 degrees according to equation number 2. Here we will subtract 3x from equation number 3, and we will get that according to equation number 3, alpha equals to 3 beta. So we got that according to equation number 3, alpha equals to 3 beta. Okay. In the next step, we will do a construction from point Q. We will draw a straight line to PR in such a way that this angle will be equal to x. Okay. So we did the straight line in such a way that this angle equals to x. But angle PQS equals to 3x. Okay, here angle PQS equals to 3x according to what is given us in the question. And we did this angle that equals to x, so the rest must be equal to 2x in order to complete the sum of those two angles to 2x, to 3x. So this angle must be equal to 2x, and we will define the touching point between the straight line that we draw to PR as point M. So here triangle QMR is an isosceles triangle because it has two angles that are equal to each other. Those two angles are both equal to x. Therefore, triangle QMR is an isosceles triangle. And the base of the isosceles triangle, triangle QMR, is QR. So we will join points M and S together by a straight line. Actually, line segment MS is the median to the base QR of the isosceles triangle, triangle QMR. MS is the median to the base QR because it bisects the base. QS equals to SR, so the median MS bisects the base into two equal parts. QS equals to SR according to what is given us in the question. But according to rule number 3, the median to the base in an isosceles triangle not only bisects the base, but it is also perpendicular to the base. That is to say, the median MS is the perpendicular to the base QR. It means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, the median to the base in an isosceles triangle bisects the base, so those two angles are right angles, they are equal to 90 degrees. And in the next step, I will present to you a new rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. That are not adjacent to it. I'll read rule number 4 again. According to rule number 4, an exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. So, what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, this angle is alpha, this angle equals to beta, this angle equals to gamma. And angle SAB, this angle SAB is defined as an exterior angle of triangle ABC. Triangle ABC has 3 interior angles that are alpha, beta, and gamma, and it has the exterior angle SAB, and according to rule number 4, an exterior angle of a triangle, that is to say angle SAB, this angle is equal to the sum of the angles that are not adjacent to it. So this angle is equal to, according to rule number 4, to the sum of the angles that are not adjacent to it. Angle gamma is adjacent to angle SAB. And the two angles that are not adjacent to angle SAB, to this angle, are alpha and beta. So according to rule number 4, the exterior angle SAB equals to alpha plus beta because of the fact that the adjacent angle, exterior angle SAB is equal to the sum of the angles that are not adjacent to it, and the sum of the angles that are not adjacent to it are alpha and beta. Okay? So the exterior angle SAB equals to alpha plus beta, according to rule number 4. And we have, if we relate to the isosceles triangle, triangle QMR, and the isosceles triangle QMR has two angles that are equal to x. And angle PMQ, this angle is an exterior angle of triangle QMR. And according to rule number 4, the value of the exterior angle QMR is equal to the sum of the angles that are not adjacent to it. And the two angles that are not adjacent to it are x and x. Okay, so actually it equals to 2x. Actually, you can easily, even without rule number 4, you can see that this angle equals to 2x because of the fact that this angle is equals to 180 degrees minus 2x, and therefore this angle will be equal to 180 degrees minus 180 degrees minus 2x, that is actually 2x. Okay, so here we actually found out that this angle PMQ equals to 2x, so therefore triangle PMQ is an isosceles triangle because of the fact that those two angles are equal to each other, they are both equal to 2x. And according to the rule that in front of equal angles in the triangle there are equal sides, we will get that PM equals to PQ. PM equals to PQ because in front of those two equal angles we have equal sides. That is to say PM equals to PQ. So you can write here that PM equals to PQ. In the next step, we will draw perpendicular from point P to QM, and then we will extend the perpendicular until it touches QS. So here, from point P, we will draw perpendicular to QM, and then we will extend it until it touches QS. So this is perpendicular to QM, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. We will define the touching point between the perpendicular from P to QM as point L, and we will define the touching point between the perpendicular from P to QS as point N. We will focus on triangle PQL and the right triangle PQL and the right triangle PLM. Okay, on the right triangle PQL, and triangle PLM, those two angles, they are equal to each other, they are both equal to 2x. So angle PQL equals to angle PML, and both angles are equal to 2x. Okay? Those two angles, they are both right angles, therefore they are equal to each other. So angle PLQ is equal to angle PLM, and both angles are right angles, they are equal to 90 degrees. I repeat again, angle PLQ equals to angle PLM equals to 90 degrees. And those two angles, this angle and this angle, they will be equal to each other according to third angle theorem. So this angle is angle QPL, angle QPL will be equal to angle LPM and those two angles will be equal to each other according to third angle theorem. So, I'll repeat again, angle QPL equals to angle LPM, and they are equal to each other according to third angle theorem. So, what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Those two angles in triangle PLQ congruent to those two angles in triangle PML. Therefore, the third pair of angles, those are defined as the third pair of angles, must also congruent because they are complementary to 180 degrees. Okay, so those two angles are equal to each other. So if we define angle PQL, this angle is theta, then angle LPM will be also equal to each other, will be also equal to theta because of the fact that both angles are equal to theta. So angle LPM also will be equal to theta. Okay. And you can see from the drawing the theta plus theta, it is actually this angle equals to alpha plus beta. From the drawing you can see that theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. So theta plus theta is 2 theta, it equals to alpha plus beta. But we have already found out that according to equation number 3, alpha equals to 3 beta. So we can substitute alpha by 3 beta in this equation and we will get that 2 theta equals to 3 beta plus beta. That is to say 2 theta equals to 4 beta. We will divide this equation by 2 and we will get that theta equals to 2 beta. Theta equals to 2 beta. So we can write here that theta equals to 2 beta. And here also theta equals to 2 beta. So here angle LPM equals to 2 beta, but angle SPM equals to beta. So if we subtract angle theta from angle beta, we will get that this angle equals to 2 beta minus beta. That is to say, it equals to beta. Okay? The angle that I marked in the red color minus the angle beta must be equal to this angle. That is to say, 2 beta minus beta equals to beta. So angle NPS equals to beta. Okay? Very simple. All this angle in the red color, it equals to 2 beta. This angle SPM equals to beta. So 2 beta minus beta will be equal to this angle that is actually angle LPS. 2 beta minus beta equals to beta. And here we know that this angle is a right angle, it equals to 90 degrees, and this angle equals to 45 degrees. So 90 degrees minus 45 degrees will be equal to this angle. 90 degrees minus 45 degrees is 45 degrees, so we found out that angle MSP equals to 45 degrees. Okay? In the next step, we will prove that those two triangles can go into each other. That is to say, triangle PNS can go into triangle PSM. So I will draw the triangles again, and we will prove that they can go into each other. So we have triangle PNS. I will repeat again. We will prove that the green triangle PNS, is congruent to the white triangle PSM. So I write it down. We will prove that the green triangle PNS is congruent to the white triangle PSM. Why they congruent to each other? First of all, we have those two angles that are equal to each other, they are both equal to beta. So angle NPS in the green triangle equals to angle SPM in the white triangle, and both angles are equal to beta, as you can see from the drawing. We have PS is a common side, it belongs to both triangles, so we can write down that PS equals to PS as a common side that belongs to both triangles, the green triangle and the white triangle. And those two angles, they are both equal to 45 degrees, therefore they are equal to each other, so angle PSN in the green triangle is equal to angle PSM in the white triangle, and both angles are equal to 45 degrees. So we actually proved that the green triangle is congruent to the white triangle according to side angle side rule. So I write it down. The green triangle, triangle P and S, congruent. This is the sign of congruent to triangle, the white triangle, triangle PSM, according to angle side angle rule. I'll repeat again. The green triangle, triangle PNS, congruent to the white triangle, triangle PSM, according to angle side angle rule. So what is angle side angle rule? Actually, if you prove that two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included in another triangle, then you proved that those two triangles congruent to each other according to angle side angle rule. Here we proved that those two angles and the side between them, that is to say PS, in the green triangle, congruent to those two angles and the side that included between them, that is to say PS, in the white triangle. Therefore, we prove that those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that NS equals to SM. NS equals to SM. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say NS and SM, will be equal to each other. So NS equals to SM. You can write here that NS equals to SM. Also, we can write here that NS equals to SM. I will join points N and M together by a straight line. And we focus on triangle NSM. In triangle NSM, this is a right angle. So we have triangle NSM. We know that angle MSN is a right angle, it equals to 90 degrees, and also we know that NM equals to NS, NM equals to NS. So those two angles must be equal to each other because they are located in front of the equal sides NS and MS, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles, they are equal to each other. So if we define this angle as y, then this angle will be also equal to 2y. So y plus y is 2y, must be equal to 90 degrees. Why? Because the sum of the angles in any triangle is equal to 180 degrees. So if this is a right angle, it's equal to 90 degrees. So the rest of the angles must be equal to 90 degrees in order to complete the sum of the angles to 180 degrees. So we know that 2y equals to 90 degrees. We'll divide this equation by 2 and we will get that y equals to 45 degrees. So we found out that this angle equals to 45 degrees and this angle also equals to 45 degrees. So angle M and S equals to 45 degrees. And this angle also equals to 45 degrees. Here angle M and S equals to 45 degrees. So we'll join points M and N together by a straight line. We found that angle M and S equals to 45 degrees. And angle SMN also equals to 45 degrees. And in the next step, we will prove that triangle PQN is congruent to triangle PNM. So I will draw the triangles again in order to clarify the picture. So we have triangle PQN, and we have triangle PMN. So we will prove that triangle PQN, the green triangle, congruent to the white triangle, triangle PNM. We have already found out that PM equals to PQ. PM equals to PQ. PM equals to PQ. PM equals to PQ. Those two angles, they are both equal to each other, they are both equal to 2 beta. So angle QPN in the green triangle equals to angle NPM in the white triangle, and they are both equal to 2 beta. And we also have a common side. PN is a common side, it belongs to both triangles, so PN equals to itself. PN equals to PN is a common side that belongs to both triangles. So we actually proved that the green triangle, that is to say triangle PQN, congruent to the white triangle, triangle PNM, according to side angle side rule. I'll repeat again. We proved that the green triangle, triangle PQN, congruent to the white triangle, triangle PNM, according to side angle side rule. So what is side angle side rule? Side angle side rule states that if two sides and the angle between them in one triangle can go into two sides and the angle between them in another triangle, then those two triangles can go into each other according to side angle side rule. And we proved that those two sides in the green triangle and the angle between them can go into those two sides and the angle between them in the white triangle. Therefore, we proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that Qn equals to Nm. Qn equals to Nm. Qn equals to Nm. Qn equals to Nm. Here we'll write down that Qn equals to Nm according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say Qn and Nm, will be equal to each other. So Qn equals to Nm. And we have the rule that, so I will copy again triangle Q and M. I will copy again triangle Q and M. So this is triangle Q and M. We found that Qn is equal to Mn. So those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. In front of those two equal sides we have equal angles, that is to say those two angles are equal to each other. But this angle equals to x, so this angle must be also equal to x. So here this angle equals to x also. So angle MNS is an exterior angle of triangle QMN. I will repeat again. This angle QMNS, this angle MNS is an exterior angle of triangle QMN. And according to rule number 4, the value of the exterior angle MNS is equal to the sum of the angles that are not adjacent to it. This angle is adjacent to angle MNS, so the other two angles that are not adjacent to it are those two angles. That is to say, angle MNS equals to x plus x. That is to say, it equals to 2x. So angle MNX equals to 2x. So we found out that angle MNS equals to 2x. But we have already found out that angle MNS equals to 45 degrees, as you can see from the drawing. So angle MNS equals to 45 degrees also. So from this equation, we will conclude that 45 degrees equals to 2x. We will divide this equation by 2 and we will get that x equals to 45 degrees over 2 that is to say it equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees. So the value of angle x, according to the second method, is 22.5 degrees. And that is the answer to the question. So in the next step I will summarize the lecture. So in the first method, here we have triangle PQR. We know that angle PSQ equals to 45 degrees, angle PQR equals to 3x, angle PRQ equals to x, and we also know that QS equals to SR, and we want to find out the value of angle x. Okay, so first of all, we defined this angle as alpha and this angle as beta, and we found the value of this angle according to the rule that the sum of the angles on one side of any straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR, we will get that at point S, 45 degrees plus this angle, that is angle X, must be equal to 180 degrees. 45 degrees plus X equals to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on the upper side of the straight line QR must be equal to 180 degrees. We subtracted 45 degrees from this equation and we got that X equals to 135 degrees. So this angle equals to 135 degrees. And then I presented to you a new rule, the law of sines. According to the law of sines, in any triangle, the law of sines apply in any triangle. If we have this triangle and we know that the length of this side is A units, the length of this side is C units, and the length of this side is B units, the angle in the opposite sides of this side is A, the angle in the opposite sides of this side is B, and the angle in the opposite side of this side is C. According to the law of sines, A over sine A over sine A is the length of A over sine A equals to B over sine B equals to C over sine C. So from this formula we can derive that A over sine A equals to B over sine B. We will multiply this formula by sine A and then we will divide it by B, and we will get that A over B equals to sine A over sine B. So it means that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. Okay? And then we see in the drawing that here PS over SQ will be equal to PS over SR. Why? Because QS equals to SR. Okay, PS over SQ equals to PS over SR because of the fact that QS equals to SR. Okay, but according to the rule that I mentioned 1 minute ago, the ratio between the length sides of any triangle equals to the ratio between the opposite angles. That is to say PS over SQ must be equal to sinus 3x over sine alpha. PS over SQ equals to sine 3x over sine alpha, and PS over SR in triangle PSR, PS over SR must be equal to sine x over sine beta. Okay. PS over SR equals to sine x over sine beta. And so we got the equation that sine 3x over sine alpha equals to sine x over sine beta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PSQ, this triangle, the sum of its angles must be equal to 180 degrees. That is to say alpha plus 3x plus 45 degrees must be equal to 180 degrees. Alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 45 degrees and we subtracted 3x and 45 degrees from this equation number 2. And we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Okay, so we express the value of alpha in terms of x. Then we focus on triangle PSR. On triangle PSR, the sum of the angles also must be equal to 180 degrees, but that is to say beta plus 125 degrees plus x must be equal to 180 degrees. Beta plus 125 degrees plus x equals to 180 degrees. We subtracted 135 degrees and also x from this equation number 3, and we got that beta equals to 45 degrees minus x. Okay, so we have the values of alpha and beta in terms of x. So we can substitute alpha and beta in equation number 1, this equation, by the values that we found for alpha and beta in equation number 2 and equation number 3. So we did it, and we got that here sine 3x over sine alpha, and alpha equals to 180 degrees minus 3x plus 45 degrees according to equation number 2, and it equals to sine x over sine beta, and beta equals to 45 degrees minus x according to equation number 3. So we substituted beta by 45 degrees minus x from equation number 3, and we have the trigonometric identity that sine 180 degrees minus theta equals to sine theta, so we can substitute sine 180 degrees minus 3x plus 45 degrees by sine 3x plus 45 degrees according to this trigonometric identity. So we did it, and we got that sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. Here we cross multiply this equation number 1, and we got this expression. Then we multiplied this expression by 2, and we got this expression. Here we simplified 2 sine 3x times sine 45 degrees minus x according to the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. In our specific equation we have A is 3x and B is 45 degrees minus x. So according to this trigonometric identity, 2 sine according to this trigonometric identity, 2 sine A sine B equals to cosine A minus B, and A is 3x and B is 45 degrees minus x, so cosine A minus B is 3x minus x, 3x minus x is 3x plus x, 3x plus x is 4x, and 0 minus 45 degrees is minus 45 degrees. So we got here that it equals to cosine 4x minus 45 degrees, and it also equals to minus cosine A plus B. So minus cosine A is 3x and B is 45 degrees minus x, so A plus B is 3x plus minus x is 2x, plus 45 degrees. Okay, so we finished with this expression. Then we treated this expression. Here a equals to x and b equals to 3x plus 45 degrees. So 2 sine a sine b equals to cosine a minus b. Is here cosine a minus b, it is actually cosine 3x minus 45 degrees minus x. So 3x minus x, here 3x, we have 3x minus x is 2x. It is actually 3x minus x is 2x, and it is 0, actually it is 3x minus x is 2x, and we have also 0 minus 45 degrees is minus 45 degrees. So it is actually a minus b. 3x minus x is 2x, and here 0 minus 45 degrees is 45 degrees. And we have also minus cosine a plus b. Again, here, I repeat again, cosine a equals to x and b equals to 3x plus 45 degrees. So we have cosine a minus b. A is x and b is 3x. So x minus 3x is minus 2x, and x and 0 minus 45 degrees is minus 45 degrees. So in conclusion, we found out that this expression equals to cosine minus 2x plus 45 degrees. But because of the fact that cosine minus x equals to cosine x, we can turn the negative sign to positive sign, and we will get that cosine minus 2x plus 45 degrees equals to cosine plus 2x plus 45 degrees. So we turn the negative sign to positive sign according to the trigonometric identity that cosine minus x equals to cosine x. Okay? And we got this expression that it equals to cosine 2x plus 45 degrees. And then we have also minus cosine a plus b. Minus cosine a plus b. A is x, b is 3x plus 45 degrees. So x plus 3x is 4x. And 0 plus 45 degrees is 45 degrees. So we got here that it equals to minus cosine 4x plus 45 degrees. Okay. And here we have cosine 4x minus 45 degrees, so we added to this equation cosine 4x plus 45 degrees, so we got that it equals to cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees. Then we added to this equation also cosine 2x plus 45 degrees, so cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees equals to 2 cosine 2x plus 45 degrees. So we got this expression. Here we have, we can use the trigonometric identity that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. And we have also here 2 cosine 2x plus 45 degrees. We can use the trigonometric identity that states that cosine a plus b equals to cosine a times cosine b minus sine a times sine b. So we start with this expression according to the trigonometric identity that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. Here we will get that C equals to 4x minus 45 degrees, and D equals to 4x plus 45 degrees. So it equals to 2 cosine C plus D over 2, C plus D. Here is 4x plus 4x is 8x, 8x over 2 is 4x, and minus 45 degrees plus 45 degrees is 0. Okay, so we got here 2 cosine 4x, and we also must to multiply it by cosine C minus D over 2. C minus D is 4x minus 4x is 0, and minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. But because of the fact that cosine minus x is equals to cosine x, we can change the negative sign to positive sign. So here in conclusion we will have cosine 45 degrees. Okay, and then we traded on the 2 cosine 2x plus 45 degrees according to the trigonometric identity that cosine A plus B equals to cosine A cosine B minus sine A sine B. A equals to 2x, B equals to 45 degrees, so cosine A is cosine 2x and cosine B is cosine 45 degrees, minus 2 sine A is 2x and B is 45 degrees, so it is sine 2x times sine 45 degrees. Then we divided this equation by 2 cosine 45 degrees, and we got that cosine 4x equals to cosine 2x minus sine 2x. Then we added to this equation sine 2x, and we got that, and we also subtracted cosine 4x, and in conclusion we got that sine 2x equals to cosine 2x minus cosine 4x, and we know that sine 2x equals to 2 sine x cosine x, and it equals to cosine 2x minus cosine 4x. And we have the trigonometric identity that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. So here we know that C equals to 2x and D equals to 4x. So cosine C minus cosine D is 2 cosine D plus C over 2. D plus C over 2 is 2x plus 4x over 2. 2x plus 4x is 6x. 6x over 2 is 3x, and we also have sine D minus C over 2, so D is 4x, C is 2x, so it's 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion we got this expression. Then we divided this equation number 1 by 2 sine x, and we got that cosine x equals to sine 3x. We use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, so cosine x according to this trigonometric identity equals to sine 90 degrees minus alpha, and it equals to sine 3x. So here, as you can see, we can derive that 90 degrees minus x equals to 3x. 90 degrees minus x equals to 3x. We added x to this equation number 1, and we got that 90 degrees equals to 4x. We divided this equation number 1 by 4, and we got that x equals to 90 over 4. That is to say x equals to 22.5 degrees. So we found out that the value of angle x is 22.5 degrees. We finished with the first method. Then I presented to you how to find out the value of angle x according to the second method. In the second method, we define this angle as alpha, this angle as beta, and this angle equals to 135 degrees. Then we made a construction from point Q. We draw a straight line to PR in such a way that this angle is equal to x. So triangle QMR is an isosceles triangle because it has two angles that are equal to x, and MS is the median to the isosceles triangle QMR. It is the median to the base, and according to rule number 3, the median to the base not only bisects the base, but it is actually perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? And but here in triangle PQS, the sum of the angles is equal to 180 degrees. So we got that alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 45 degrees from this equation, and we got that angle alpha equals to alpha plus 3x equals to 135 degrees. In triangle PSR, the sum of the angles also equals to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. So we got that 3 beta plus 3x equals to 135 degrees. So we can write down that equation number 1 equals to equation number 2. That is to say, alpha plus 3x equals to 3 beta plus 3x. We subtracted 3x from this equality equation, and we got that alpha equals to 3 beta. Then we did the construction that I talked about it, and we have actually rule number 4 that an external angle of a triangle is equal to the sum of the angles that are not adjacent to it. That is to say, the external angle SAB equals to alpha plus beta, because alpha and beta are the two angles that are not adjacent to angle SAB. So we can implement rule number 4 in our drawing. According to rule number 4, the external angle of triangle QMR, this angle PMQ, will be equal to x plus x. That is to say, it will be equal to 2x. So here we have an isosceles triangle because it has two angles that are equal to each other, and we know that in front of equal angles in the triangle there are equal sides. That is to say, PQ equals to PM, PQ equals to PM, and we draw perpendicular from point P to QM. So this angle is 90 degrees and this angle is 90 degrees, and we define the point, this point is point N. Then we proved that those two triangles, actually we have those two angles that are equal to each other. They are both equal to 2x. Those two angles are right angles, therefore they are equal to each other, and those two angles will be equal to each other according to third angle theorem. Okay? That is to say, angle QPL equals to angle LPM according to third angle theorem. So if this angle is theta, then this angle must be also equal to theta, because those two angles are equal to each other. From the drawing you can see that theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. So 2 theta equals to alpha plus beta. According to equation number 3, alpha equals to 3 beta. So we can substitute alpha by 3 beta. We did it, and we got that 2 theta equals to 3 beta plus beta. That is to say, 2 theta equals to 4 beta. We divided this equation by 2, and we got that theta equals to 2 beta. So here theta equals to 2 beta. Here this is angle theta that equals to 2 beta. So this is angle beta. And theta equals to 2 beta. So if theta equals to 2 beta, this angle is beta, this angle must be also equal to theta in order to get that beta plus beta equals to theta. And we have this angle equals to 45 degrees. and this is a right angle, so this angle must be equal to 45 degrees in order to complete the sum of those two angles to 90 degrees. So we proved that those two triangles congruent to each other. Why they congruent to each other? Because they have two angles that are equal to each other. They have PS is a common side, and those two angles are also equal to each other. They are both equal to 45 degrees. From the fact that those two triangles congruent to each other, we will conclude that SN equals to SM. Okay, according to the rule that corresponding sides and congruent triangles are equal to each other. So SN equals to SM. We join points M and N together by a straight line. This is a right angle. So those two angles must be equal to 90 degrees. And those two angles must be also equal to each other because of the fact that MS equals to SN, and in front of equal sides in the triangle there are equal angles. Okay, so if an angle is y, then the other angle will be also equal to y. So we can write down that 2y equals to 90 degrees. 2y equals to 90 degrees. We divided this equation by 2 and we got that y equals to 45 degrees. So this angle equals to 45 degrees and this angle also equals to 45 degrees. So this angle MNS equals to 45 degrees. And this angle also equals to 45 degrees. Then we proved that those two triangles can go into each other. Why? Because they have two angles that are equal to each other. First of all, PM equals to PQ. PM equals to PQ. Those two angles are equal to 2 beta. And PN is a common side, so those two triangles can go into each other according to side angle side rule. Therefore, NQ equals to MN. NQ equals to NM. And we join points M and Q together, and we got triangle MNQ. In triangle MNQ, we know that MN equals to QN, and we know that this angle equals to X, so this angle must be also equal to X in order to, according to the rule that in front of equal sides in the triangle there are equal angles. So if this angle equals to X, this angle must be also equal to X. Okay, so in triangle QMN we have exterior angle M and S, and the value of the exterior angle M and S is equal to the sum of the angles that are not adjacent to it. That is to say, it equals to 2x. So angle M and S equals to 2x from one side, but we have already found out that angle M and S equals to 45 degrees. From this equation, we will get that 45 degrees equals to 2x. We divided this equation by 2 and we got that x equals to 22.5 degrees. So we found out that angle x is equal to 22.5 degrees. Okay, so in both methods we found that the value of angle x is equal to 22.5 degrees. Okay, thank you very much.